Okay, so this is how to do a Big Mama or heating curve problem. So your first step, you're going to mark up what the question's asking you to do. So we're being asked to solve for energy. We know that we have 10 grams of water. We know that our temperature change is -25 to 57 degrees. The key here to know if you're doing one of these problems is the fact that we were asked to solve for energy and that we have two temperatures. So my first step is I'm going to draw this heating curve, this Big Mama. It's already drawn here for you, but on the test you're going to need to be able to draw this out. Your next step is to mark the freezing point for the substance. So in this case, because we're talking about water, the freezing point is 0. So I'm going to put 0 right there. And then the boiling point is going to be with this upper flat line. So I'm going to look over here at the table, and it tells me that water has a boiling point of 100 degrees Celsius. Now that I have this set up, I need to actually draw my roadmap of where my heat is going. So the first thing I'm going to do is I'm going to look over here at my first temperature. That temperature is -25. So if I look on this y-axis, I know that -25 is below 0. So I'm going to go ahead and I'm going to mark that to remind myself. My end point is going to be 57 degrees Celsius. That's where I need to end. So I'm going to go up and I'm going to see that 57 is in between 0 and 100. So I'm going to place a dot there, and that's my destination, 57. So I'm going to treat this like it's my drive to school. So here's my house, here's school. I'm going to drive down this street and then turn. Drive down this street, then turn. Drive down this street, and here I am at Gilbert High. So now this means that I have 1, 2, 3 calculations that I need to do. So there's a different calculation for each line segment. The first line segment is a slanty line. Anytime you use a slanty line, you're going to use this equation, which is Q equals M times C times delta T. So I'm going to go ahead and I'm going to start plugging in all the values that I know for this problem. My mass is 10 grams. The C value, because I'm talking about water and I'm on the solid portion of the heating curve, I'm going to go like this on my table until I figure out that my C value is 2.1. Finally, my delta T for this specific segment is going to be this dot minus this dot. So 0 minus -25 ends up being a difference of 25. I'm going to take my calculator. I'm going to do 10 times 2.1 times 25. And that tells me that I needed to use this much heat to do this line segment. Now line segment 2, this is a flat line. The flat lines have special equations. The lower one is called delta H fusion. The upper one is delta H vapor. So because this is the lower line, I'm going to use Q equals M times delta H fusion. And this one's easy because all you have to do is put your mass in, which is 10. And then you need to find your delta H fusion value for the substance you're talking about. So in this case, because it's water, it's going to be 335. I'm going to multiply those across, and I'm going to figure out that in order to melt my ice cube all the way, I need to use that much energy. Finally, for our third calculation, because this is a slanty line yet again, we need to use Q equals M times C times delta T. My mass is staying the same this whole time, so that's 10. Now to find my C value. This is a solid down here, which means this slanty line right here is a liquid. So when I look here at water liquid, I find out that my C value is 4.18. The last step for this calculation is I need to figure out what my delta T is, how many miles I drove from this dot to this dot. So because we started at 0 and ended at 57, our delta T is 57. I'm going to plug this in the calculator, 10 times 4.18 times 57, and I get 2,382.6 joules to heat up from here to here. Now I just have to add it all up, so I'm going to say 525 plus 3350 plus 2382.6. And my final answer is 6,257.6 joules to heat my piece of water up from -25 degrees Celsius all the way up this curve until 57 degrees.